So today is the first of two lectures on input and output, and today we're going to be focusing on reading from and writing to files. In the next lecture we're going to be talking about how you format output and how you do single character input. So for starters, IO streams involve something called objects and classes. And it's a new concept. We're going to go over it briefly here and then in more detail later in the course. So the idea behind objects is that they model things that you might have in the real world. So think of an alarm clock that may maintain information such as the current time, the alarm time at which you want to get up, whether the alarm is on, and so on. And so that's kind of the output information. And then it has information or ways to manipulate this information. So it has dials and buttons, switches that allow you to change this information. And it also then has digital displays that display it. So the digital displays are the output, and the dials and the buttons and the switches are the input elements that manipulate the state. So we talk about this first part here as kind of being the state information about the object, and then we talk about this latter things as being the way to manipulate and display that information. So in C++, there's a way to model real-world objects, but obviously they can't be physical objects, so we call them virtual objects. And C++ objects have a way of collecting information in one place. So they can store what's called heterogeneous information. And here we're storing the hour, the minute, the second, whether it's AM or PM, and the current temperature. So this would be state information. This is just a high-level conceptual idea. We won't get into the actual way that it stores that information until later in the course. And then C++ objects have member functions, which are also called methods, and they allow you to query that information. So that would be equivalent to the alarm clocks displaying it. And to change the state information, that would be equivalent to the buttons and dials that allow you to manipulate the information. So here's some sample member functions. These ones allow you to query the information in the object, and these ones allow you to set that information or change it. So I/O is based on this notion of a C++ object. They give you stream objects, and whether you have realized it or not, cin and cout, the two variables that you've been using throughout the course, they are stream objects. They contain information about some entity. So for example, cin is keeping information about the input console where the user is entering data. Cout keeps information about the output console where they're outputting information. For example, cout might keep track of the current position in the line so that when it prints next, it'll print at the right position. When it sees a new line character, it'll update the line to be a new line number and reset the column it's printing at to 0. So the types of information that are kept in these stream objects include formatting information. So for example, cout, also when you call precision, it keeps that, allows it to set the number of decimal places to print. For cin, it includes whether the input is exhausted. So there's ways to tell C++ that there's no more input, and then where you are in the input. So to make sure that when you do the next read that you get the next available value. And then methods, well, so far you've seen operators for reading and writing data. The less than operator writes data, and the greater operator reads data. And there's also for output objects methods to change the formatting information. So the rest of this lecture is going to talk about streams and file I/O. The rest of this agenda will be covered in a subsequent lecture. So an I/O stream, the reason they're called streams is an analogy to water in a creek. And in the creek, water just kind of flows linearly through the creek, and that's the same thing that happens with C++. Well, you may type what's shown here on the left as cat, dog, bear, and panda on 4 separate lines. That's not how C++ is presented the data. It sees it as a single continuous line of data. So to C++, input consists of one very long line of values, and hence we call it a stream of characters. And thus that's the name for the objects, stream objects. So again, and the other thing is to say new lines are ignored in the input. So it's just new lines are treated like white space, basically. So a stream is a flow of data, and they flows into your program via stream objects. It can be from the keyboard, in which case you use cin, or it could be from a file, which we discussed in a separate lecture. And then the screen represents cout, or is represented by cout, or we can also write to a file. For example, if we're writing a photograph, we want to write that to a file. So as you learned in a previous lecture, files are permanent repositories of information, and they can be either human readable, which are going to be the types you'll create in this course, or they could be binary files that have special encodings, and you saw several in previous lectures like picture files or video files. You won't be creating those in this course. So we're going to start by talking about input files, or start by talking about input from file systems. And input files contain data we want processed by a program. So they could contain exam scores, it could contain data from weather stations, it could be data from telescope observations. Basically, we don't always want to have to input information on the console. It's long, it's tedious, and sometimes we're gathering information from, say, sensors. It'd be much nicer if these sensors could just write their observations into some file, and then in turn we could read those observations into our program without having to type them in through the console. And again, file I/O uses stream objects. You're going to use an IF stream object for input and something called an OF stream object for output. And what you see here is from the IF stream class and the OF stream class, basically classes are like blueprints that describe the object. They describe the state information, they describe the methods that are going to be allowed to access and manipulate this information. So here's an example with us reading from a file called cs102.dat, and we're reading exam scores. We're going to compute a weighted average for the student's exam score and then write it out. So you see that in order to connect, well, first of all, here's our declarations. So we declare exam scores to be an IF stream, so it's going to represent an input file, and grades is going to represent an output file. So the first thing in our program is to actually associate real files with these variables, and we do it with the open method. So we open cs102.dat, which we assume contains the exam scores, and we open cs102 finalgrades.csv, which is where we want to write our weighted averages to. And then we're going to assume that our scores come in the form, we're going to assume that every line has the form of a name and then 2 midterm scores and maybe then a final. So 3 scores, and the first data element is the name. So just leave that here so you can see that for a moment. And therefore we're declaring a student name string variable for holding the student name and 3 variables for holding the 2 midterms in the final. And finally, we want to have the weighted average, and we want that to be an int. We're not interested in storing it as a double. So now we need to read our input lines, and we do it with this while statement. And you see that we put the read statement as the condition for whether we do another iteration of the loop body. And that's because the read statement will return false when it's exhausted the input in the input file. When it's read the last line of input, it'll return false and will exit the loop. You'll also notice that reading input looks just like reading it from a console, except now instead of using cin, we use the name of the IF stream that we're reading from, which in this case is exam scores. And once we've read a line, we calculate our weighted average, and even though the right-hand side expression is computing a floating point number, it'll get truncated when it's assigned to weighted average. And then, rather than printing the result to the console, we're printing it to this OF stream object named grades, which is going to write it out to this file cs102 finalgrades.csv. And again, output to it looks just like output to cout with the less than operator, except instead of using cin, we use grades. And a CSV file, for those of you who don't know, is a comma-separated list of values. So in this case, we write out student name, then a comma, then weighted average. So a comma is used to separate the values in a comma-separated value. Then the final thing we do is to close the files once we're done using them. If we exit the program without closing them, typically the operating system will do that for us, but it's good practice to make sure we close them explicitly. And that breaks the connection between the variable name and the file. It also does some cleaning up and writing, making sure that the file is actually written to the disk. So to use file IO, we have to remember to include the file stream library because it contains the definitions for the IF stream and OF stream objects. So in addition to including IO stream, which includes the definitions for cin and cout, you now also need to include F stream if you want to read to or read from or write to files. And as I just said, the greater than and less than operators behave just like you expect from their behavior with cin and cout. The greater than operator reads input from a file, and the greater than or less than operator writes values to a file. But again, instead of using cin, you use the name of the file from which you're reading for input. Instead of using cout, you use the variable associated with the file that you're writing to. And again, the open function is used to associate an actual physical file with our variable name. So that's how we associated cs102.dat with exam scores, and the way we associated cs102 finalgrades.csv with the grades variable. And this dat ending basically just says it's like a text file. There's the way you end the file name tells both the operating system and the application, gives hints about what might be stored in that file. .dat tends to imply it's a plain text file. Okay, and note the dot notation for calling an object's member function. So first comes the name of the variable, then a dot, and then the name of the function that you're calling. So in this case, we're calling the open function associated with exam scores. Now, if you're going to access these files in Code Light, you need to be careful about where you put them so that you know how to access them properly in your programs. So the first way you can do it is to simply place the file in the debug folder. Remember, a folder is called a directory associated with your project. So as an example, my workspace on my Mac is located in users/bvz/cs102, and my project is named A3. So I would go to the path name for it is to concatenate the project name with my workspace name, and then CodeLight creates a debug directory for you, which is where it's putting your main.cpp. So if you put your file into that directory, you can simply open that file by giving the name of the file. If you want to put it in a directory that's not the same directory as your program is in, then you're going to have to provide a full path name. By default, C++ looks in the same directory that the program is executing in if you do not provide a file name. But when you provide one, it follows the path. So remember from the file systems lecture that paths are either forward or backslash delimited lists of directories with the last element representing the name of a file. And if you put your file somewhere other than in the debug directory associated with the project you're working on, then you're going to have to provide the full path name when you open your file. And the close member function, again, it severs the link between the file and the stream variable. It tells the operating system that we're done with this file. And as I say, it's important to use it because even though normally things work properly, if you forget the close function, it's not guaranteed. So it's a good idea to explicitly call close to make sure that the file actually is permanently created. And it's only called after you have finished processing the file, because if you call it before then, it's no good. You've severed the link now between the file and the IO stream, and when you go to use that stream object, C++ will get confused. Bad things will happen. So you've got to consider the fact that when you try to open a file, it may fail. And there's two reasons it may fail. You mistyped the file name, so the file name doesn't exist. Or you may not have permission to access the file. Okay? Maybe multiple people use the computer and you don't have permission. Sometimes the file is protected. It's owned by the operating system. The operating system doesn't want you accidentally tampering with its files and changing them. How would you feel if a virus got on your computer, was able to open up something in the operating system? Well, viruses are clever and they sometimes figure out how to do it anyhow, but the operating system does try to protect you by checking to see whether you have permission to access the file or not. So you should always check after you call open to see whether it succeeded. You can do that with the fail method, and it returns true if the open method failed. So here, after opening exams, I then check to see whether it failed by calling the fail method. And again, notice the .fail after exam scores. So I have to provide the stream that the method is associated with. And then I use this function. You haven't seen it yet. We'll talk about it in a moment, called perror, or for print error. And it prints an error message. And then a second function you haven't seen, exit, which causes us to exit the program. And the parameter or argument 1 tells the operating system that it's an abnormal exit. If we exit it with 0, it'd be considered a normal exit from our program. In the old days, these codes for exiting made a difference. These days they tend to be ignored. So just normally 0 means we succeeded if we call exit, 1 means we're exiting abnormally. So the print error message, or perror function, prints a message. And in fact, the message that you pass it is appended to a message that the that C++ prints for you. So typically it's going to be the name of your file in this course. That's because C++ is going to be printing the reason for the failure when you call print error. Basically, there's a special place where it stores a message indicating why an operation failed. When you call print error accesses that message and prints it out, and it first concatenates your message to the front of it. So normally by passing the file name, it'll say something like, okay, file does not exist, and it will prepend your name to it. Okay, so you've already seen this code from a previous slide. I'm just going to move on at this point. So exit is a function that immediately exits your program, and it's part of the C standard lib library, so you have to include it, otherwise your compiler may give you an error message saying this function is undefined. And it differs from return in that return returns from a function, but it doesn't exit your program, whereas exit immediately terminates your program. And you typically only use it when something's gone wrong with your program and you want to exit immediately and indicate that it's an abnormal exit. Now, when we went through the code, we also talked about something called end of file. And you saw this line or expression in the while statement. Remember that I said that when it reaches end of file that the read operator returns false to indicate there's no more input. And this is a perfectly good way to write your input statements. I like it a lot. And it actually can fail for reasons other than just end of file. Another reason it can fail is because it can't convert the next value in the stream to the type expected by the variable. So for example, here I have a variable midterm1 declared as an int, and I'm trying to read a value from exam scores into midterm1, but let's say the next value in exam scores is the string Brad. Perhaps I forgot I only entered, say, 2 or 1 exams rather than 3, and so C++ went to look at the next line of input, tries to read the string variable Brad, and has no idea how to convert it to an int. In this case, you'd also get a error. In this course, we're not going to be so concerned with the second source of an error because you, in that case, need to do some checking of your values, some resetting of the stream, and it's a little bit advanced. So we're going to primarily just worry about end of file as being the reason that the input operator returns false. Okay, but if we really needed to know whether we've reached end of file or whether we failed because we were not able to convert a value successfully, we can call a function called EOF, which will return true if the end of file has been reached and false otherwise. Whereas fail is more generic. It returns true if the last read failed, but it could be for some reason other than just EOF. So if we really care about finding out if the failure was because of reaching end of file, then we really should call the end of file method. So this is a second way using EOF to terminate or to check whether we've reached end of file, and we could write a while loop this way, where we say while not in stream.eof. So while we haven't reached end of file, let's keep going. So which way is preferable? Well, for this course, I really feel like the first way is much less error prone. You'll see why in a moment, and more intuitive to read. So, but in general, we're going to be using EOF later in the course, not really right now, but when we need to do character-oriented I/O and we need to use a get function, which you haven't seen yet, to get either a line or to get an individual character, we have to use the EOF method. But if we're processing numeric data or we're just processing strings, then typically we can use what I call the extraction operator. If it's easier for you to think of it as that, the greater than greater operator when processing numeric data or really string data as well. Now here's the pitfall with EOF, and it's going to be confusing. You'll probably have to get bitten by this bug a couple times before you get it right. And the problem with EOF, let me illustrate. Here's some code. And what I'm doing is I want to read the words from this file foo, which has hi Brad, and then I want to write them to cout. And so a natural way to do it is to say, okay, open my file, then while I haven't reached EOF, let's read a word from print file and print it out. And you run the program and you find out that the last word in the input file gets printed twice, and you're baffled. Why did that happen? And the reason is that the EOF function does not return true until C++ has actually read a special EOF character that marks the end of the file. So if you could look at foo, it really looks something like what you see here, as though there were 3 words in it: hi, Brad, and then EOF. And the problem is that after it's done the second read, so it's gone through the loop twice, and first it read hi and then it read Brad, it still hasn't seen this EOF character, and so when you call the EOF function, it returns false. And you go into the loop one more time and you try to read this print file and it reads EOF. And at this point, the operator, the input operator, greater than returns false, sets the EOF variable to be true. It doesn't change what was in Word. So you go ahead and you again print out what used to exist in Word, which is Brad, and you printed it twice. So there's a solution to this problem, which is priming reads. You have to use priming reads just like you've been doing in the rest of the course if you're going to use the EOF method. So here's the right way to do it. After you open the file, you do your priming read, and this way if the file's empty, you'll never actually go into the loop body. And it happens where files are empty. But in this case, it would come in and say, okay, it's not EOF, would print the word out, and remember that the contents were hi Brad. There it is right there. So after reading hi, the second time through, it's going to read Brad into Word. Come up here, it's not into file, so it prints Brad right here. Reads it again, and now it encounters that special EOF character. And it leaves Word as Brad, but it sets the EOF variable in print file to be true. And so when we come now up here and ask, have we reached EOF? The answer is yes, and we exit the loop. So if you're going to use the EOF method, remember to use a priming read before entering your loop body. Okay. The final thing about file names is that it's very easy when you hard code the file name as a string, but you'd think that the open method would accept a string variable as well, and it turns out it doesn't. It's not set up to handle C++ string variables, and we're not going to go into them in this course. It really wants an older type of string called a C-style string. And the way you can basically get at a C-style string is to call the C underscore string function on a C++ string. So if I, here I have prompted the user for the name of the exam score file instead of hard coding it, and I read it into file name, and now when I go to open the file, I have to call the .c underscore string method to get file name, which is a string variable, to return the older kind of string that open expects. Okay, if you'd failed to do that, the C++ compiler is going to give you an error message saying it doesn't recognize this as a valid string type. Okay, and finally, sometimes you want to append data to an existing file. You might have had maybe every day you read some weather observations, and at the end of each day you process them and then add them to a pre-existing file. So normally when you open a output file, it clobbers the existing file. It wipes it out and starts a new one from scratch. And that's something you don't always want to have happen. So if instead you want to append output to an existing file, then you use this constant called app, which is in the iOS library, which you get for free when you include iOS Stream. And in that case, you would open the file and then include a second parameter, iOS : app, that would tell the C++ compiler to append any output to this file rather than creating a new file. However, if the file does not already exist, then it will create a new file from scratch for you. Okay, and then again in the next lecture we're going to be moving back to console output and talking about how you can format your output and then how to read character input.